Imagine a night sky ablaze with vibrant hues, dancing and shimmering like celestial flames. This is the captivating spectacle of the Aurora Borealis, more commonly known as the Northern Lights. A symphony of colours illuminating the night, painting the heavens with strokes of green, blue, pink and violet. But what is the science behind this ethereal display? The Northern Lights, primarily visible in high-latitude regions, have been a source of wonder and inspiration for countless generations. From ancient myths and legends to modern scientific exploration, the Aurora Borealis continues to hold us spellbound. Join us as we delve into the science behind this celestial marvel, unraveling the secrets of nature's most awe-inspiring light show. For centuries, cultures around the world have woven myths and legends around the Northern Lights. In Norse mythology, the aurora was said to be the shimmering armor of the Valkyries, female figures who decided who would live or die in battle as they rode across the sky. Some Inuit communities believed the lights were the spirits of their ancestors, dancing and playing games in the heavens. Today, while we understand the scientific principles behind this celestial phenomenon, the Aurora Borealis continues to hold a mystical allure. While the myths and legends surrounding the Northern Lights are captivating, the science behind this phenomenon is equally fascinating. It all begins with our Sun, a giant ball of hot gas that constantly releases a stream of charged particles known as the solar wind. The Earth, with its protective magnetic field, acts like a giant shield, deflecting most of these charged particles. But our planet's magnetic field is not uniform. It's weaker at the poles, allowing some of the Sun's charged particles to enter our atmosphere. As the Sun's charged particles collide with atoms in the Earth's atmosphere, they transfer their energy, causing the atoms to become excited and release light, creating the mesmerizing display we know as the Aurora Borealis. Our journey to understand the science behind the Aurora Borealis begins with the Sun. The Sun, a churning ball of hot gas, is constantly releasing a stream of charged particles, a kind of solar wind that carries energy across vast distances of space. The Earth's magnetic field acts as a shield, deflecting most of the Sun's charged particles, keeping our planet safe from this constant barrage. However, the Earth's magnetic field is not uniform in strength. It's weaker at the poles, allowing some of the Sun's charged particles to slip through this protective barrier. These particles, guided by the magnetic field lines, are funneled towards the polar regions, setting the stage for the celestial spectacle of the Aurora Borealis. As the Sun's charged particles, primarily electrons, enter the Earth's atmosphere, they encounter a new obstacle: the atoms and molecules that make up our air. Each collision transfers energy, causing the atoms to become excited. This excitation, however, is a fleeting state. To return to its ground state, the excited atom releases the extra energy it gained from the collision, and it does so in the form of light. This emitted light is what we perceive as the vibrant colours of the Aurora Borealis. Different atoms, when excited, release different colours of light, creating the beautiful and varied palette of the aurora. This is how the mesmerising display of the Northern Lights is formed. The colours of the Aurora Borealis are not random. They are determined by the types of atoms that are being excited and the altitude at which these collisions occur. The most common color of the aurora is green, produced by excited oxygen atoms at an altitude of around 60 miles. At higher altitudes, around 120 miles and above, collisions with oxygen atoms can produce a rare, all-red aurora. This deep red hue, less common than the typical green, adds a touch of mystique to the already stunning display. Like a crimson curtain drawn across the heavens, it's a sight that leaves onlookers breathless. While the Aurora Borealis graces the skies of the Northern Hemisphere, a similar spectacle unfolds in the Southern Hemisphere, the Aurora Australis, also known as the Southern Lights. Both auroras are the result of the same phenomenon, the interaction between the Sun's charged particles and the Earth's magnetic field. The Southern Lights are often less observed than their northern counterpart simply because there is less landmass and therefore fewer people at high southern latitudes. However, when viewed from places like Tasmania, New Zealand, or Antarctica, the Aurora Australis puts on a show just as dazzling as its northern twin. The Sun, our star, is a giant ball of hot, electrically charged gas called plasma. From this churning sea of plasma, a stream of charged particles, mostly electrons and protons, is constantly escaping. This stream of particles is what we call the solar wind, travelling at incredible speeds, reaching up to 1 million miles per hour. The solar wind carries with it the Sun's energy and magnetic field, spreading it out across the solar system. Our planet isn't just a rocky sphere hurtling through space. It's a dynamic system with its own protective force field, the Earth's magnetic field. This field is generated deep within Earth's core, where molten iron is in constant motion, creating electrical currents that produce this magnetic shield. This magnetosphere acts like a shield, deflecting most of the harmful radiation and charged particles carried by the solar wind. Without this magnetosphere, the solar wind would strip away our atmosphere, making Earth a very different and much less hospitable place. While the Earth's magnetosphere deflects most of the solar wind, it's not a perfect shield. The magnetic field lines converge at the poles, creating weaker points in our planet's defences. These weaker points at the poles allow some of the charged particles from the solar wind to enter our atmosphere. The Earth's magnetic field guides these particles towards the polar regions. This funneling effect is crucial for the formation of the auroras, concentrating the charged particles at high latitudes, setting the stage for the stunning light show. The charged particles, guided by the Earth's magnetic field, don't just rain down randomly at the poles. They form distinct oval-shaped regions of auroral activity known as the auroral ovals. These auroral ovals are not static. They expand and contract depending on the intensity of the solar wind. During periods of high solar activity, the auroral ovals can expand towards the equator, making the auroras visible at lower latitudes. It's within these ovals that the magical interaction between the Sun's breath and Earth's shield creates the breathtaking display of light we call the Aurora Borealis and Aurora Australis. The Aurora Borealis is renowned for its vibrant greens. But this celestial spectacle isn't limited to a single hue. Each colour tells a story, a tale of the interaction between the sun's breath and the Earth's atmospheric tapestry. The most common colour, the iconic green, arises from the excitation of oxygen atoms at lower altitudes, around 60 miles above our heads. At higher altitudes, above 120 miles, where the air is thinner and oxygen atoms less abundant, a different shade emerges. Excited oxygen at these heights emits a rare all-red aurora. This crimson hue, less frequent than its green counterpart, adds an element of mystique to the auroral display. The Aurora Borealis isn't just a static display of colour, it's a dynamic performance, a celestial ballet of constantly shifting shapes and patterns. Imagine a curtain of light rippling in a gentle breeze, or waves crashing on an ethereal shore. The aurora's movements are as captivating as its colours. One of the most common forms is the auroral arc, a graceful curve of light that stretches across the sky. Auroral arcs can be thin and subtle or wide and brilliant, their edges sometimes sharp and well-defined, other times diffuse and hazy. As the intensity of the solar wind increases, the auroral display becomes more dynamic. These dancing forms, known as auroral curtains or draperies, create a mesmerizing spectacle, a breathtaking testament to the invisible forces at play in the cosmos. Beyond the green curtain, uncommon auroral hues add a touch of uniqueness to the night sky. Blue and purple hues, less common but equally enchanting, result from the excitation of nitrogen molecules in the atmosphere. Blue auroras often appear at lower altitudes, where nitrogen is more abundant. Purple hues, even rarer, typically appear as fringes or borders on the green and blue displays, adding a touch of royal elegance to the auroral spectacle. These uncommon colours are a testament to the dynamic nature of the aurora, a reminder that this celestial ballet is a performance with infinite variations. Throughout history, the Aurora Borealis has been more than just a natural phenomenon. It's been a source of artistic inspiration and a thread woven into the fabric of folklore and mythology. Imagine ancient storytellers gathered around flickering fires, sharing tales of the celestial dancers that illuminated the night sky. These stories, passed down through generations, reflect the awe and wonder that the aurora has inspired for centuries. In art, the aurora has been depicted in various forms, from cave paintings by early humans to masterpieces by renowned artists. Early rock carvings, found in Scandinavia and dating back thousands of years, suggest that our ancestors were captivated by this celestial display. These carvings often depict the aurora as abstract shapes and patterns, capturing the essence of its ethereal beauty. Dance of the Spirits. Myths and legends of the Northern Lights. Ancient cultures often attributed the Aurora Borealis to supernatural forces, weaving it into their myths and legends. For the Inuit, the aurora was the spirits of ancestors, dancing and playing games in the afterlife. In Norse mythology, the aurora was associated with the Valkyries, who escorted fallen warriors to Valhalla. From superstition to science, unraveling the aurora's mysteries. Myths provided imaginative explanations, but the quest for scientific understanding continued. The journey was gradual, marked by observations and new technologies. Aristotle described the aurora as burning flames in the night sky. Galileo named it Aurora Borealis, after the Roman goddess of dawn and the Greek god of the north wind. Today, while we understand the scientific principles behind the Aurora Borealis, it hasn't lost its power to inspire awe and wonder. If anything, our understanding of its celestial origins has only deepened our appreciation for this natural phenomenon. The aurora continues to be a subject of scientific study, with researchers using advanced technologies to unravel its complexities. Satellites monitor the sun's activity, providing early warnings of potential auroral displays. Ground-based instruments measure the aurora's intensity, altitude, and the types of particles involved, providing valuable data for understanding its dynamics. Beyond the realm of science, the aurora remains a source of artistic inspiration. Photographers and filmmakers travel to remote locations, braving frigid temperatures to capture its ethereal beauty. Musicians and writers draw upon its otherworldly allure, creating works that evoke a sense of wonder and connect us to the cosmos. Chasing the Northern Lights. A guide to auroral adventures. Witnessing the captivating dance of the Aurora Borealis is an experience like no other. The aurora is a natural phenomenon, a fleeting masterpiece painted across the night sky. Chasing the Northern Lights is an adventure, a pursuit of the elusive and unpredictable. Venture into the auroral zone, where the Northern Lights are most frequently visible. This zone includes Alaska, Canada, Greenland, Iceland, Norway, Sweden, and Finland. Remote areas, far from light pollution, provide the darkest skies for viewing. Timing is everything when and where to witness the spectacle. The best time to witness the Northern Lights is during the winter months, from September to April. The nights are long and dark, providing ample opportunity to catch a glimpse of the elusive aurora. The displays are most vibrant around the equinoxes, in March and September. Clear skies are essential, as clouds can obscure even the brightest auroral displays. Patience is a virtue essential tips for aurora viewing. Chasing the Northern Lights requires patience and a sense of adventure. The aurora is a fickle performer, appearing and disappearing at will, its intensity waxing and waning throughout the night. It's a waiting game, a test of your perseverance, but the rewards are well worth the effort. To enhance your chances of witnessing a memorable auroral display, consider joining a guided tour. Experienced guides are familiar with the best viewing locations and can provide valuable insights into auroral activity. They can also offer tips on photography and help you capture stunning images of this celestial spectacle. Dress warmly, as temperatures in the auroral zone can drop significantly, especially during the winter months. Bring a thermos of hot cocoa or tea to stay warm while you wait, and a comfortable chair or blanket to sit on. The aurora often makes its grandest appearances in the early hours of the morning, so be prepared for a late-night adventure. Epilogue. A celestial symphony to remember. The Aurora Borealis, a celestial ballet of light, is a testament to the awe-inspiring forces at play in our universe. From the heart of our sun to the edges of our atmosphere, a cosmic dance unfolds, painting the night sky with breathtaking hues. More than just a light show, the aurora is a reminder of the interconnectedness of our planet with the cosmos, a celestial symphony that has captivated humankind for millennia. As we've journeyed through the science behind this natural wonder, We've uncovered the secrets of solar winds and Earth's magnetic field. The excited dance of atoms creates the aurora's vibrant colors. We've explored the myths and legends inspired by this celestial display. Stories that reflect our ancestors' attempts to understand the universe. And we've ventured into the heart of the auroral zone, armed with knowledge and a sense of adventure, hoping to catch a glimpse of this elusive and mesmerizing phenomenon. The Aurora Borealis is a humbling experience, a reminder of the vastness and mystery of the universe we inhabit. It's a call to look up, to marvel at the celestial wonders that surround us, and to appreciate the delicate balance of our planet within the cosmos. Whether you're fortunate enough to witness this spectacle firsthand, or simply gaze upon its beauty in photographs and videos, the Aurora Borealis is a reminder that some wonders transcend time and place, igniting our sense of wonder and reminding us of the beauty and majesty of the universe we call home.